Question number 111. The primary CO2 acceptor in a C4 plant is. In a C4 plant, there are double carboxylation or the double CO2 fixation, first in the mesophyll cells and then in the bundle sheath cells. The primary CO2 acceptor is PEP, phosphoenol pyruvate, which is a 3-carbon molecule and it's found in the mesophyll cells, because primary CO2 fixation occurs in the mesophyll cells. And then the second carboxylation or the second CO2 fixation takes place in the bundle sheath cells, where a 5-carbon molecule called RUBP is the acceptor for the CO2. So the primary CO2 acceptor is found in the bundle sheath cell? No. Is a 3-carbon molecule? Yes. Present in mesophyll cells? Yes. 5-carbon molecule? No. B and C are correct. So the correct option for the given question is option number 2. Let's move to the next question. Question number 112. Plants showing Cran's anatomy do not tolerate higher temperatures. No, they can't tolerate the higher temperatures. So this is incorrect. Why? Because these are the plants which are called the C4 plants, which show Cran's anatomy and they can easily tolerate the higher temperatures. Their temperature optimum is high. Second one, they do not show response to high light intensity. No, they show response to high light intensity. Fourth one, they do not show greater productivity than C3 plants. No, they have greater productivity than the C3 plants. Third option, they do not show photorespiration. Yes, they do not show photorespiration. It is true because here Rubisco cannot show its oxygenase activity, hence photorespiration is absent. So the correct option for the given question is option number 3. Let's move to the next question. Question number 113. The difference between number of ATP required to form a molecule of hexose sugar in a C4 and C3 plant is. Now, you can compare a C3 and C4 plant. To fix a single CO2 molecule, a C3 plant requires 3 ATP, whereas a C4 plant requires 5 ATP molecules. Because it's a hexose sugar, we have to fix 6 CO2 molecules. 6 into 3, 18 ATP molecules are required in a C3 plant, and 6 into 5, 30 ATP molecules are required in a C4 plant. What is the difference? 30 minus 18, that is 12 ATP. So a C4 plant requires 12 more ATP than a C3 plant. So the correct option for the given question is option number 2. Let's move to the next question. Question number 114. State true or false for the following statements and choose the correct option. Statement A. Glycolysis operates as long as it is supplied with NAD+ that can pick up hydrogen atoms. Statement B. Alcoholic fermentation results in the release of CO2 while lactic acid fermentation does not. Both the statements are correct. See the statement B. It is easy. Alcoholic fermentation results in the release of CO2. While alcoholic fermentation is taking place, there is release of CO2, but in lactic acid fermentation there is no release of CO2. It is true. Statement A says that glycolysis operates as long as it is supplied with NAD+ that can pick up hydrogen atoms. It is true that NAD+ pick up the hydrogen atoms, and if NAD+ is supplied to the glycolysis, it can operate. So this is also true. So the correct option for the given question is option number 1. Question number 115. Living organisms retain the enzymatic machinery to partially oxidize glucose to pyruvic acid. This statement is applicable to the enzymatic machinery to partially oxidize glucose to pyruvic acid. This process is glycolysis. Glycolysis is common to aerobes as well as anaerobes. So it is found in all organisms, whether they are respiring aerobically or anaerobically. See the options. Aerobic eukaryotes only? No. Anaerobic prokaryotes only? No. Only some organisms respiring anaerobically? No. all organisms either respiring aerobically or anaerobically. It is true, glycolysis is common for all living organisms, whether they are respiring aerobically or anaerobically. So the correct option for the given question is option number 4. Let's move to the next question.